So this video today is all about effective annual interest, EAR, or sometimes referred to as APY, annual percentage yield. Now the reason we need to worry about this is because when we talk about compounded interest, if a person said they were getting 5% a year but compounded monthly, in fact you're going to get more than 5%. It's not going to be a lot more, but it's going to be a little bit more over the course of the whole year. So in other words, we can look at this by saying a nice easy example. Suppose we take $100, like that's a pretty nice easy amount. Pretty much any idiot can figure out what percentage, 5% of that is. Of course, over the course of the year, if you got 5%, you should have $5. Okay, but what we've been doing is the idea of compounding. So we've got 1 plus interest divided by 12. That's for month 1. It's the end of January, for instance, all the way down to the end of December. So as you can see, we don't have $105. We have $105.12. So we've made, there's a couple ways to do this problem. So if I want to find out what percent it is, I can take the ending balance divided by the initial balance minus 1. And then if I do that, I get 0.051, or in other words, 5.11% interest. That would be your APY, or your effective annual rate. So in other words, if I had just paid you interest once a year, so for instance $100, and then down here below it just simply said equals the previous value times 1 plus, and then this amount here, but just one time, boom, hey look, it's the same amount of money. What do you know? Now it doesn't look quite the same because it's not in dollars, but if it was in dollars, wow, look at that. What do you know? It's the same. Okay? So that is a nice way for, kind of like when you go to Winco or someplace of that nature and you want to know about, is this a better bargain than this? They have it priced out per ounce, per pound, per ding dong, whatever it happens to be, so that you can then see which one's the better one. It's very similar here. Now obviously if everything is compounded monthly, then obviously when the higher percentage, when the higher number they quote you is going to be the better deal, period, because obviously if everything else is the same, then that's the better deal to start with. But if a person said, well, I can get 4.9% compounded monthly at one bank, or I can get 5% semi-annually, that means twice a year, okay, which is the better deal for me. And so I'm going to cheat and just do this one because it's already right here. Boom. So I give them 49% interest. That would be cool. That won't happen. So if you look at that, that would be our effective annual rate, all right, for getting 4.9% compounded on a monthly basis. Now if I were to do the same thing, and again the initial amount doesn't matter, it makes it easier for us to see it. I could just as easily have done 1,000 or 1324. Oops, not there though, you moron. How about you do it at the top one? There you go, 1324. Boom. Notice how this didn't change. The percentage rate stays constant. Okay, but I'm going to stay with $100 just because that seems easy. And I'm going to go equals the previous amount times parentheses 1 plus. Now I'm just going to go ahead and hard code it. So I'm just going to type in 0.05 divided by 2. Okay, because again, not divided by 12, divided by 2 semi-annually. And then do it again, and drag that baby down. And look at that, what do you know? I got $105 and a penny here, I got $105 and 6 pennies over here. What's the EAR over here? Well, again, it's final divided by initial minus 1. Boom. And so this is the better deal. If someone will give you 5% semi-annually, that is a better deal than 4.9% compounded monthly. It is important to note, okay, when you take out a loan or anything of that nature, whenever they talk about APY, it's as if you were just putting money in an account and leaving it sit there, okay? Or owing somebody money would be the same deal, but not paying off on it, okay? So it's, if you want to find the APY, it's always just let it here and then let it grow by our 1 plus interest divided by however many times. Go down 1 year, and then there you go. Now I could have driven this down to the end of 2 years. And interestingly enough, all I would have to do is take the ending balance after 2 years divided by the beginning balance at the start of the second year. It's the same value. That will always be true. It doesn't even have to be mid-year. It could be from here and then count back 12 months. So that's going to be tricky for me. 1, 2, 3, 4. If I didn't schmuck it up, hey, it's the same. So for any, in this case, 12-month period, that's good. For over here, it'd be for every 6-month period. So here is, from here to here is 6 months. So if you did that over here, just go equals, just go boom, divided by boom, minus 1. What do you know? It's the same value. Okay? Now again, this 2 years. 2 years over here puts me down to right there. That is 2 years here. That's 2 years over here. This over here, if you drag it down, that's 3, 4, 5, 6, 7, 8. That's 8.5 years. Okay? 8.5 years over here, I'd have to drag it down to like, what, 103 or something to get the same, to get to the same time frame, 8.5 years. So that's kind of an interesting way to do it. There is a way for those of you who are kind of Excel junkies to do that with a formula. So if you, and again, I wouldn't do that with a formula, and I'm a math guy. I would not use the formula. I would just take the ending balance divided by the beginning balance minus 1. That is the way to do it. But what a person could do is they could do it like this. So the rate, well, so the number of periods was 12, right? We're doing this monthly interest business. And the, oh, stupid dogs. 0 payment. Previous value. One moment, please, while I go thump a dog. Get the dumb dog next door finally shut up. So, how to do this if you want to use a formula is you want to go to financial. Oh, dog, what is it? Try it again. Then I have to rate. Again, one of the 5 players that come up every time we're dealing with financial stuff. So, in the case of monthly interest, we're going to do, So what we're trying to find here is we're doing effective annual rate. In other words, it's as if I was paying you interest once a year. What percent interest would I have to give you in order to pull this off? So 1, the payment is 0. We're not putting anything in it. The present value, 100. Future value, now this is where it's a little creepy. You have to put in negative 105.01 right there. Okay, that guy right there on A13. You could have clicked on A1 here too if you wanted to. Hit OK, and that pops up. And you're like, 5%? That's what I started with, Jay. You're what? Or no, it's actually 4.9%. But you're like, that's weird. Here's the deal. This thing always gives it to you in whole decimal numbers for percentages. I don't know why. It kind of irritates me. So what you can do is click on this little increase deal right here, and you can add as many decimal places as you like. Well, what do you know? It matches that basically. So, yay. Okay. And so there it is. Okay. So it's 5.011%, and there's the deal. 5.01. See this? 5.0116. I don't know why I gave it so many decimals. I should have backed off. Let's go. There you go. See, they match. Isn't that pretty? This and this match. Yay. So that's a way to do it with the rate formula. It's kind of a neat deal. It's not too hard either. But again, I prefer just click and drag method, and then always it's equals ending balance divided by beginning. Oops, beginning balance. Minus 1. Obviously that formula won't work the way I've typed in, but that's what you do. You can just click on them or you can type them in. That's how you find APY or EAR.